Dear students, in this video I am going to teach you about the hydrogen and some of the characters of the hydrogen. So first let us see the introduction about this. If you see hydrogen, it is the simplest atom which contains one electron and one proton. That is, the only element which does not have the neutron is hydrogen. It has only one electron and one proton. And even when you say the element, we usually say octet, that is the outermost orbit contains 8 electrons. So only 2 elements which cannot attain the octet is hydrogen and the helium. So both are the first period elements. The hydrogen contains only 1 electron and the helium contains 2 electrons. 2 in the sense it is completely filled, and hydrogen it is half filled. So its valence electron is directly in the sphere of action of nucleus. It is invariably present in most of the compound. When you see water, carbohydrates, proteins, fats, everything, whatever we use in the day-to-day life, it contains the hydrogen mostly. And it has an unpaired electron. It has only 1 electron. So it is reactive and always exists as a diatomic molecule. Immediately when a fresh hydrogen bonds, it will combine with the another hydrogen and it will form the H2. It will not be as a atomic hydrogen. Always it will be present as a hydrogen molecule which contains 2 atoms of hydrogen. Though the hydrogen is present in the carbohydrates, water, proteins, fats, etc., 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 when you see the atmosphere, the presence of hydrogen is very less. Mostly we say the 75% of the atmosphere is surrounded by the nitrogen and the 23% and above by the oxygen, and the remaining only covered by the other gases. So it is present in the atmosphere in a very small amount only. And when you see the periodic table, we already studied about the periodic classification in the third lesson. S block element, P block element, D block element and the F block element. So where this hydrogen should be placed? That is a great question. If you see the hydrogen, its electronic configuration is 1s1, which resembles the alkali metals which have the electronic configuration ns1, so that we can think it can be placed above the alkali. Still, we have to learn about the property of the hydrogen, which have both the properties of the alkalis as well as the halogens. So first let us see how it is similar to the alkalis. This forms the unipositive ions, that is H plus ions, as same like the alkali metals, which will form, we know alkali metals, sodium, potassium, rubidium, cesium, lithium, etc. They can be also formed as sodium ion, Na plus, potassium ion, K plus, cesium ion, Cs plus, like that. This hydrogen is also forming the H plus ion, that is the hydrogen ion. So it forms the halides, oxides, peroxides as same as the alkali metals. Hydrogen combined with any halogen to form the hydrogen halide. If it combined with the chlorine, it will form hydrogen chloride, as same as, for example, sodium. If you take in the alkali, sodium forms the sodium chloride. Like this, the halogen is also the hydrogen is also forming a hydrogen chloride. And the oxide, if you take, hydrogen combines with oxygen to form the water, that is the oxide of hydrogen, and it will react with the oxygen again to form the peroxide also. Like this, the alkalis also can able to form the, for example, if I take the sodium oxide, sodium peroxide, sodium sulfides, like that. So as like the alkalis, this hydrogen can also form the halide, oxides, peroxides and the sulfides. And this is a strong reducing agent. The hydrogen is a strong reducing agent. But when you compare the ionization energies, the ionization energy of the alkali metals are they ranges from 377 to 520 kilojoules moles inverse 1. But when you take for the hydrogen, it is almost double or triple, I can say. It is 1314 kilojoules moles inverse 1, which is double or triple the amount of the alkalis. So which is very much higher than that of the alkali metals. So though it is forming a unipositive ion like the alkali metals and forming the halides, oxides, peroxides and also being a reducing agent, when you take the ionization energy differs more. So now let us see how it is having the properties like the halogens. The halogens forms halides. As same, hydrogen also form hydride. For example, with nitrogen it will form ammonia. Here when you take the hydrogen is taking a -1 valency. So it is gaining an electron. So to attain the noble gas configuration. However, the electron affinity if you take, you know what is the electron affinity? It is a energy it is energy released when an electron is accepted by an atom. So however, the electron affinity of the hydrogen is much less than that of the halogen's atom. Hence, the tendency of hydrogen to form hydride ion is low when you compare to the halogen forming the halide ion. If you take the hydrogen, it accepts the electron by observing the energy of 36 kilocalorie moles inverse 1. But at the same time, if you take the bromine, which is a halogen, it is giving out -55 kilocalorie mole inverse 1. So, the electron affinity value differs more. So, since the hydrogen has the similarities with the alkali metals as well as the halogen. So, for us it is being difficult to place the hydrogen in the periodic table. Where to place it? Whether to place above the alkali metals or to place above the halogen metals. So, and this here we conclude the most of the compounds of the hydrogen carries the +1 oxidation state as like that of the alkalis. So, it is reasonable to place the hydrogen in the group 1 along with the alkali metals. Nowadays, you can see in the periodic table, it was placed above the lithium, which is a alkali metal. And now let us move to the isotopes of the hydrogen. We know what is isotopes. The elements having the same atomic number but different mass number. That is due to the presence of number of neutrons in a nucleus differs. As I informed as earlier, the hydrogen which has only one proton and one electron, it does not have the neutron. That is called as a protium and it is indicated by H11 or merely H. If it contains one neutron, then the mass number will become 2. Now this can be indicated as H12 or D. It is called as deuterium. Suppose if it have 2 neutrons, then its mass number became 3. This is indicated by H13 or T. So mostly if you take the hydrogen contains 99.985 parts of protium and 0.015 part of deuterium. And if you take the tritium is a radioactive isotope and only you can see it is a out of 1018 Out of 1018 atoms of hydrogen, one atom will be the tritium. So due to the existence of these isotopes, naturally occurring hydrogen will be existing as either hydrogen molecule or hydrogen with deuterium or deuterium molecule or hydrogen with tritium or tritium molecule and with the deuterium with the tritium. So here you can see the picture. First one, if you see the protium contains the one proton and one electron. When you take the deuterium contains one proton, one electron, along with that you have one more neutron. If you take the tritium, it contains two neutrons, one proton and one electron. So now let us see the properties of these isotopes. So how much the properties of these differs. First, when you go for the symbol, protium is H, deuterium D and tritium T. When you take the atomic mass, the protium atomic mass is 1.008, deuterium is 2.014 and tritium is 3.016. And the electron proton neutron ratio, as I told you earlier, for the protium for the protium 1 electron, 1 proton, no neutron. For the deuterium, all the three are present 1, 1, 1. And for the tritium, proton and electron 1 and the neutron 2. So the stability, if you say, the protium and the deuterium are stable, whereas the tritium is a radioactive element which is having the half-life period of 12.3 years. And how it is represented? Protium is represented as H2, deuterium as G2 and tritium as T2, and the how much it is present I have told you already, and the molecular mass also we have seen already. And now let us see the melting point. If you see, it is differing. The melting point of the protium is 13.96 and deuterium is 18.73 and tritium is 20.62. And for the boiling point, it is 20.39, 23.67 and 25.04. What is the internuclear distance between the one atom and the another atom? If you take the protium, the internuclear distance is 74.14 picometer. For deuterium, 74.14, as well as for the tritium also the same thing. Then the critical temperature. The critical temperature you have studied already in the thermodynamics. So what is the critical temperature of the protium? It is 33.19. For the deuterium it is 38.35 and for the tritium it is 40.60. And the bond dissociation energy for these also differ only in a small ratio. And now let us see one more thing, that is ortho hydrogen and parahydrogen. Already we have seen the isotopes of hydrogen. The isotopes of hydrogen rises due to the presence of the number of neutrons in the hydrogen. And what is this, the ortho and the parahydrogen? We all know the electron revolves in the orbit. The same time, the protons which is present in the nucleus also they will be spinning. So if the proton spin, if you take the hydrogen atom, the nucleus has a spin. When the molecular hydrogen is formed, if the protons in the both the hydrogen atoms are spinning in the same direction, then it is called as the orthohydrogen. If they are spinning in the opposite direction, then it is called as the parahydrogen. See here in this one you can see, this is one hydrogen atom and this is one hydrogen atom, and this is the proton present in the first hydrogen. This is the proton present in the second hydrogen. If you see the red arrow mark, both the arrow marks are going in the same direction, showing that the protons are spinning in the same direction. The same thing I have represented here as a arrow mark. Okay. So if you take the parahydrogen, the electron will be spinning. You know, apart from that, the proton will be also spinning. If you take this hydrogen, the proton is spinning inward, and here also the second one also the proton is spinning inward. So they are spinning in the opposite direction. So there are two types of hydrogen, orthohydrogen, parahydrogen in the molecular hydrogen. If the protons in the molecular hydrogen spins in the same direction, it is called as the orthohydrogen. If they spin in the different direction, then it is called as the parahydrogen. So now let us see the composition of that. If you take in the room temperature, the 75% of the hydrogen molecules have the spin in the same direction, that is called as a 75% ortho form, and the remaining 25% will be the para form. As the ortho form is more stable than the para form, the conversion of the one isomer into the another isomer is a slow process. But still the equilibrium shift in the favor of parahydrogen at a low temperature. At the low temperature, we can get 99% of the hydrogen as the parahydrogen. The normal temperature, 75% will be ortho and 25% will be para. But when the temperature is lower, now you can get 99% of para and 1% of ortho. So the same, the para form can be catalytically transformed into ortho form. So by using the catalyst, we can change the ortho into the we can change the para into the ortho by using the platinum or iron. Alternatively, it can be converted by passing the electric discharge. Heating above 800 degrees Celsius and by mixing the paramagnetic molecules such as the oxygen, nitric oxide, nitrogen dioxide, or with the nascent or atomic. Nascent means newly born hydrogen, that is the atomic hydrogen. By using that, you can change the para form to ortho form. Then this, when you go for the chemical properties and the physical properties, the chemical properties will be same for both the orthohydrogen and the parahydrogen, but some of the physical properties will be differing. Example, if you take, the melting point of parahydrogen is 13.83, while for the orthohydrogen it is 13.95. Same thing for the boiling point also. The boiling point of parahydrogen is 20.26 Kelvin, whereas for the orthohydrogen it is 20.39 Kelvin. And when you go for the magnetic moment, the nuclear spin are opposite direction in the parahydrogen. So its magnetic moment is 0. In the orthohydrogen, both the spin are in the same direction. So its magnetic moment will be twice than that of the proton. So that I have given you some of the informations about the hydrogen, children. In the next class, let us see the preparation and the properties of the hydrogen in detail. Thank you, children.